Hi, I would like to introduce you to the jinja2 templating language and its use inside the Agile Open Container. Huawei's Agile Open Container uses the Jinja templating language to translate API requests to network configuration. The form these templates take is to specify the static configuration as applied to your devices and specify it in standard XML. Some attributes though will change or vary across devices. These can be sent on the API specified by the service unit, or can be retrieved or calculated at runtime based on request or runtime information. How these parameters are mapped or transformed can be complex, with different combinations of parameters applied based on API data or the type, role, or position of the target network element. Jinja provides an expressive, extensible templating language and engine to simplify this definition and operation for the user. Jinja2 is a designer-friendly Python templating engine. A jinja2 file is a text file and does not have a specified extension name, but by convention for IDE tools, the extension J2 is usually used. The template contains three parts: fixed configuration, which is applied as seen in the rendering output, seen here in blue; control logic, which is used to execute control logic statements, seen here in green; variables or expressions, which are used to print the expression result to the specified position in the rendering output, seen here in black. Control structure refers to statements that can control the rendering of the template, such as if, else, for, and include. The control structure is presented as a percent block and itself is not printed in the rendering output. The if and for statements are similar to the if and for statements in Python. The if statement checks whether a variable is defined or empty, or evaluates whether an expression is true or false. To define multiple conditions, a programmer can use a combination of if, else if, and else statements. The break and continue statements can be used inside for loops. The break statement allows you to exit a loop when condition is met. The condition statement allows you to skip over a particular iteration of a loop when a condition is met. To add comments, a jinja2 template uses a hash block. These comments are excluded from the rendering output. In the default configuration, the template engine will not modify the whitespace, such as spaces, tabs, and new line, which will be returned without any change. A minus can be placed at the beginning or end of a code block to remove the whitespace before or after the block. Large templates can be broken down into smaller blocks and managed using the include statement. A good design rule is if the template is rendering multiple target Yang models, each Yang model should be broken into a subtemplate. These subtemplates can then be concatenated together using the include statement in the parent template. In the example shown, the interface management feature templates statements are defined in ifm.j2, and the code for the network instance feature is defined in network instance.j2. These subtemplates are included in the master template as shown using the include statements. Variables can be modified through filters. Filters and variables are separated by a pipe symbol, and optional parameters are enclosed by parentheses. Multiple filters can be invoked by chaining the invocations, that is, the output of a filter is used as the input to the next filter. Filters also support parameters enclosed by parentheses. As with calling a function, the parameter on the left of the pipe symbol is transferred as the first input parameter of the method on the right of the pipe symbol. In this example, objects in the list are separated by a comma, and the resulting list is used as the rendering result. Jinja comes with a number of pre-created filters for data manipulation that can also be used inside of AOC. Additional custom filters can be defined and added. In AOC, Jinja can be invoked in two ways. The first is where there is no Python extension and the template is invoked directly from the service API request. In this scenario, Jinja2 template is specified in the hooks section of the SSP's package.json file and is called automatically once the service API is invoked. The second is where there is a Python extension. In this case, the Python is invoked programmatically directly in the Python using the NCE map API. Using the NCS map method, you can invoke the Open SDK API of the AOC to write your own decomposition logic. The self.render executes the jinja2 templating rendering action and takes two parameters: the path to the jinja2 template and the context data that the jinja will use to map network configuration. In this example, the NCS map method renders the template using the received request data without any modification, but in practice this is where the request data will be added to or augmented. The output returned from the template execution is an XML string, which is then sent to the mapping algorithm to calculate the configuration changes for the target device. Okay, let's look at a real example of jinja2 inside of AOC. On the left hand side you see the service line model that specifies the input. On the right you can see the mapping template. The first thing to notice is the inventory config tag on the template. This is the root node of all jinja2 templates in AOC. It has only one subnode, namely NEs, which can contain one or more NE subnodes to specify the Yang XML configuration data of the device. The next thing to notice is that normally the service model in Yang, its root node is specified as a list node. In this way, multiple list entry nodes can be created through the AOC northbound API. In the example, the subinterface service node in the Yang model on the left has two child nodes, leaf device and a list subinterface, where the device is the list key and indicates a specified device. The list subinterface allows the specification of multiple subinterfaces. The subinterface service entry is used as the input of the jinja2 template. In line 4, you can see the device ID is obtained based on the device name. In line 7, the for loop corresponds to the list subinterface. In line 9, subinterface.if name is used as the value of the if name in the rendering result. And similarly in line 10, subinterface.description is used as the value of the if description. Finally, let's look at what happens if we execute the template. Using the Service API input for device 1 with ifname1 and ifname2, the template renders the result on the right. For more information about jinja2, see the jinja2 template designer documentation and AOC Open SDK API. Thank you.